Operators have a major challenge to provide the best quality of service with a reasonable investment, while experiencing variable load levels due to end-user mobility behavior and traffic demands. A great solution to this problem is the application of oran architecture and the traffic steering use case to monitor the real-time load levels, and based on the current traffic levels and radio conditions, take action to load balance the end users between cells. In this demo, we will present the collaboration between Juniper Networks, Rimedo Labs, and Keysight for the integration and demonstration of the traffic steering use case. To illustrate the use case, let's consider a scenario where the middle cell is experiencing heavy load. Near real-time RIC and traffic steering XApp, through continuous performance monitoring, detects this heavy load and decides to steer some of the end users to the appropriate neighbor cells based on certain network conditions and operator policies. The demo setup includes the traffic steering XApp from Rimedo Labs, running on and utilizing the open APIs of Juniper Near Real-Time RIC, and Juniper Near Real-Time RIC connecting via E2 interface to Keysight RICtest, which is emulating a cluster of cells and end users. Juniper Near Real-Time RIC, which is a very mature RIC platform with full compliance to ORAN standards, provides open APIs for third-party developers to enable rapid development, integration, and portability of applications. Juniper and Rimedo work together to utilize these open APIs by Rimedo's traffic steering XApp, and Juniper and Keysight work together for E2 integration between the RIC and the RICtest.
For traffic steering, Keysight RICtest is providing emulation of aggregated and disaggregated Gnode Bs, which expose standards-based protocol implementation for E2 interface, supporting the KPM and RC service models. Cell Canvas provides information regarding cell layout and mobility path for UEs in test. User interface provides statistics to the user about the success of traffic steering and handover completion.
The aim of Rimedo Labs Traffic Steering XApp is to associate users with cells on the basis of multiple factors like radio conditions, cell load, and service profile identified by 5QI. The Traffic Steering XApp inherits two key features: load balancing, aimed at equalizing the load between cells, as visible in the bottom left part of the picture, and service-based traffic offloading, aimed at associating users with cells according to their quality of service flow characteristics, as illustrated in the bottom right part of the picture. The behavior of Traffic Steering XApp can be controlled by A1 policies, both for load balancing and traffic steering features. First stage is the deployment of Traffic Steering XApp. For this purpose, we use the graphical user interface of Juniper RIC. We click on this block with XApps per Near Real-Time RIC. Now we can see a list of available XApps. We select the Rimedo Traffic Steering XApp. As we see, it is ready to be deployed. Now we click to deploy the XApp. As no additional configuration is needed, we leave JSON empty and click OK. After a few seconds, XApp is successfully deployed. In the top left window, we see a Kubernetes cluster of Juniper RIC with Rimedo Traffic Steering XApp deployed therein. We now select the XApp pod to monitor logs. Below, there is a command line interface of Traffic Steering XApp that will be used to set traffic steering policies. On the right side of the screen, there is a graphical user interface of Keysight's RICtest. We click to start the test. After a while, a test is started, and we can observe subscription requests and responses taken by XApp. Next, cell info appear, followed by the connected UE information. Within the Keysight RICtest window, a dashboard is displayed with general statistics. We now click on the traffic steering dashboard in the Keysight's RICtest. The dashboard now shows the traffic steering specific statistics, mainly user-to-cell association. Suppose that some high-level energy-saving algorithm decided to switch off cell 4. The traffic steering XApp can be used to offload users from this cell before it is switched off. For this purpose, we formulate a proper A1 policy. As a result, in the XApp logs window, we see multiple handovers offloading users to the neighboring cells. We also see that the traffic steering dashboard is updated, showing that users are now moved to cell 3. Also, the handover statistics were updated for cell 4, showing 100% of success rate. In the meantime, the traffic steering XApp takes care of switching the users between cells on the basis of their radio conditions. We see that some users were moved from cell 3 to cell 2. As you have seen, the Rimedo Traffic Steering XApp is integrated with Juniper RIC and can be used for flexible user-to-cell association in 5G radio access network emulated by Keysight's RICtest.